polycystic ovarian syndrome. Now, some of us may have been officially diagnosed with PCOS and some have not been. For those who have not, you'll notice some troubling symptoms occurring within your body, ranging from number 1 to 11. Then you go to the doctors to have some tests done, and the doctor would then tell you some not so noticeable symptoms, ranging from number 12 to 22. Now, why do these symptoms occur? This research report will let you know the reasons for PCOS symptoms found within Section D and E of the report. So do have a read on these PCOS symptoms ranging from number 1 to 22. Now, these PCOS symptoms are wide-ranging, and you will notice that it is not just related to fertility. In fact, the name of this disorder is actually confusing because it involves endocrine issues and not just a fertility problem. Section D of the research report explores the impact of stress on the neuroendocrine. When we face a worry, anxiety, or fear type of stress, this would trigger 5-alpha reductase enzyme to be more than 0, which then triggers the adrenal gland to produce cortisol hormone to counter the stress. But when we face a chronic stress, there will be a situation called cortisol steal, whereby cortisol hormone is produced at the expense of the sex hormones, because both these hormones share the same base hormone, which is pregnenolone. So, cholesterol from the liver would then be prioritized to be transformed to pregnenolone and ultimately cortisol by the adrenal gland. Now, the adrenal gland would overwork to produce cortisol hormone to counter the stress. With the overworking of the adrenal gland, this would then attract free radical attacks to the gland. Now, with free radical damages at the cell of the adrenal gland, there will be a situation of malabsorption of oxygen, nutrients, and water to the gland. Next, the liver also overworks to increase cholesterol, which is a precursor to pregnenolone, in order for the sex gland to transform pregnenolone into sex hormones. The sex gland also overworks to replenish the depleting sex hormones. Now, free radical attacks will come in at both the liver and the sex gland. Now, with regards to the liver, there will be free radical damages at the estrogen receptor alpha. There will be also inflammation at the liver and oxidative stress. Stress causes pancreas via glucagon hormone to signal the liver to release glucose to the blood. Pancreas via insulin hormone signals muscles, including liver, to take in glucose or energy from the blood to counter the stress. Any unused energy or excess glucose is then redirected back to the liver to be absorbed as glycogen. However, due to free radical damages at the liver, there is problem in absorbing the excess glucose. Therefore, the excess glucose is then redirected to be absorbed at the fat cells or triglycerides, and this leads to higher lipogenesis with symptoms such as high triglycerides or high obesity. So with high obesity in a low estrogen body, this would then promote central obesity, a key symptom of PCOS. Now, in future, when energy is required to counter stress, the body will not take in energy from the liver due to the lower glycogen storage. Instead, it will take in energy from the muscles or fat cells, and this is termed as gluconeogenesis, which further depletes the body's protein stores and worsens protein catabolization. Now, with a weak liver, it will have difficulty absorbing insulin produced by the pancreas, and this is termed as insulin resistance, Hence, the pancreas has to overwork to produce more insulin so that it can be absorbed by the liver, and this is termed as diabetes type 2. So with the overworking of the pancreas, this would then lead to free radical attacks at the pancreas, and therefore causing malabsorption of oxygen, nutrients, and water to the pancreas. Therefore, pancreas will start to get fatigued and produce little or no insulin, and this is termed as diabetes type 1. T4 or thyroxine is converted to T3 at the liver. However, with a weakened liver, you'll be unable to properly absorb T4, so therefore the thyroid needs to overwork to produce more thyroxine to be absorbed by the liver, and this situation is reflected as hyperthyroidism. However, with the overworking of the thyroid, it would then attract free radical attacks to the thyroid organ, and when the thyroid is weakened, it would then produce less thyroxine, and this is a situation of hypothyroidism. Damaged membrane cells from free radical attacks lead to an inefficient transportation of oxygen, nutrients, and water to the cell. Oxygen is required for hydroxylation and oxidation process. Hence, hydroxylation process is impaired, leading to inefficient conversion of cholesterol from the liver to steroid hormones, meaning pregnenolone, which is a base ingredient for cortisol, progesterone, testosterone, estrogen, vitamin D, and other hormones. The sex gland has problems replenishing depleting sex hormones via cholesterol from the liver, while the adrenal gland has problems replenishing cortisol via cortisol from the liver. Next, liver's inefficient synthesis of cholesterol from squalene, liver's inefficient conversion of cholesterol into bile salts. Lastly, the impaired liver's detoxification process. Hydroxylation problems, where the sex gland's inefficient conversion of cholesterol to sex hormones, resulting in an imbalance or low sex hormones level and cortisol still, cause irregular menstrual, low sex drive, fertility issues, ovulation problems, and polycystic ovaries. Hydroxylation problems, where the sex gland's inefficient conversion of cholesterol to sex hormones and the adrenal gland's inefficient conversion of cholesterol to cortisol, will result in increasing total cholesterol. The liver's inefficient synthesis of cholesterol from squalene will result in increasing squalene, which is largely found in sebaceous gland. Squalene is secreted into VLDL and LDL and distributed to various tissues. So a backlog of squalene will result in increasing VLDL and LDL cholesterol. A lowered bowel movement will cause malabsorption of fat-soluble vitamin D and E that reduces production of HDL cholesterol from the intestines. Therefore, an impaired hydroxylation process will lead to an increasing total cholesterol level, an increasing squalene level, which means predisposition to acne, an increasing VLDL and LDL cholesterol levels, a decreasing HDL cholesterol level. So, the summary impact of an impaired hydroxylation process here would be a weak cholesterol profile with cholesterol plaques and cardiovascular risk, leading to an increasing blood pressure due to the fact that these cholesterol plaques would be deposited at the blood arteries, and also leads to kidney problems due to the fact that the kidney will have more restrictions in filtering the blood that is restricted by the cholesterol deposits. Hydroxylation problems, where the liver's inefficient conversion of cholesterol into bile salts would lead to bowel sluggishness, and this would then cause bad bacterial buildup, constipation, toxin buildup, gut issues such as diarrhea, trapped gas, lower metabolism or digestion of fats for energy, accumulation of liver fats, and leading to non-alcoholic fatty liver disease, and if it's worsened, cirrhosis, malabsorption of fat-soluble vitamin A, D, E, and K. Now, with these low vitamin levels, for instance, low vitamin A, the impact would be impaired vision, low immunity. For low vitamin D, the impact would be low immunity, infertility. For low vitamin E level, the impact would be a reduction in antioxidant to neutralize free radicals and thus higher inflammation, skin health impairment. With regards to low vitamin K, the impact would be easy bruising and reduced blood clotting. Methylation and hydroxylation problems will impair the liver's phase 1 and 2 detoxification process. Therefore, there will be toxin buildup, imbalanced hormone and neurotransmitters, which will impact the liver and the brain respectively.